Now we're going to find the inverse of an exponential equation, and it should help that we've just solved a bunch of these. So I want to go back to that original statement that we started with, which was log base value equals to exponent. And when we set up our logarithm statement, we can only have a base, we can only have a value, and we can only have exponents in the exponential equation. What you'll notice in this statement right here is that we have a base, we have a value, and we have an exponent. And that exponent is just a complex exponent. If we had anything outside, like something attached to that base, like a 2, or we were adding to the function like plus 20, we'd end up having to do some division and subtraction before we actually got into our logarithm statement. But none of that exists. So I'm going to say log. I'm just going to set it up. Log with the base is 4. And the value is y equals to an exponent of 3x plus 5. And when we find the inverse, one of the main goals is to solve for x. And that's where we're going to start. I'm going to get rid of that positive 5. I'm going to subtract 5. And when I subtract 5, it's really important to note that that subtraction of 5 is outside of this logarithm. Okay? And when we type it into Desmos, we're going to need to pay attention to that. So I'm left with 3x, and I'm going to divide by 3. So we are left with x equals to log base 4, y, all minus 5, all divided by 3. And the last thing we would do is write our inverse statement, which the original was g of x. So I'm going to write g inverse of x. And I'm just going to switch around. Log base 4 x minus 5 over 3. Now let's go to Desmos and verify our equation for 3x plus 5 versus our logarithm for the inverse. So I'm going to come and I'm going to call it g of x equals to 4 caret, and I'm going to open parentheses around that exponent, 3x plus 5. If you don't open parentheses around that exponent, it's going to probably drop that exponent into 2 pieces, and you don't want to do that. You want to represent that whole value in the exponent. Then we're going to come in and we're going to type in our inverse. So f of x, remember we have to just give it another name. And I'm going to come over here and say functions, and I'm going to go to log a. And when I do this, I'm going to make sure that I put it all in parentheses because it is going to be the numerator. So 4 up x. And then I'm going to close out that parenthesis. Whoops. And then outside of the log base 4x, I'm going to subtract 5 from the whole value. And I'm going to close parentheses, then divide everything by 3. We need to make sure that it looks like that. Now, as we look at this, I'm going to plug in our reflection line. And if you recall, our reflection line is the y equals x line. And you can see that the black line, or the black exponential equation, looks to be a mirror image of the log, or the log looks to be a mirror image of the exponential. But we can verify by using the composition of functions that we've been doing in all of our inverses. And we would say g of f of x. And notice what happens. It lights up, which verifies that we've found the inverse correctly.